Hello students, welcome to the new session. Today we will be discussing about the limits concepts. So what exactly limits? When do we use this limits? What is the necessity of doing this one? For example, if someone is saying f of x is equal to x square minus 4 by x minus 2. So what is this? In normal language, we'll say this value is equal to x plus 2. Is it so? No. This is clearly like f of x is equal to x plus 2, where x is not equal to 2. Where x is not equal to 2. Why? Because when you are cancelling both numerator and denominator some term, that value cannot be equal to 0. Means you will be writing here x minus 2 into x plus 2 by x minus 2. So if you are cancelling this one, means this should not be equal to 2. So if anyone talk about f of x is equal to x square minus 4 by x minus 2, that means the graph is going to be y is equal to f of x plus 2. Okay. So this is x is equal to. So now what happened? This is f of x values I can find everywhere, but at x is equal to I cannot find the value. So if I'm unable to find that x is equal to functional value is not defined, so what is happening? So then what we will do as x is going to approaching to. So how many ways you can approach to? From left side, that is called x minus 2. So here x is less than 2. As extending to 2 plus, you are approaching from right side. That is x is greater than 2. Approaching from left side, approaching. So when you are approaching, whatever this value is approaching, that is the called left limit. And when you are approaching from right side, that is called right limit. So here what happened? X plus 2 you take. So as x is approaching 2 from left side, it is like 3.98, 3.99, 3.99999 like this. When you're approaching right side, 4.01, 4.001, 4.0001. So when you're approaching from left side, it is going to 4, from right side also approaching 4. So we will write limit extending to 2, f of x is equal to 4. So that is called the limit value. When you are unable to find out the functional value, then you need to mean f of x. Something is mentioned, x is not equal to a. Something is given here. So now what happens if I want to find f of x, which is not possible. So in that case, what happens? We'll find limit extending to a f of x. So when you want to take this one also, you need to check limit extending to a minus f of x. It should be equal to limit extending to a plus f of x. So here also certain important things. For example, limit extending to 0, x square plus 2x plus 3 by x plus 1. So directly you substitute. So you will be getting 3 by 1. Limit extending to 0, x square plus x by 2. This value is 0. Only thing is where the problem comes, when limit extending to 0, x square plus 2x by x. Now this is when you apply 0 by 0 form comes. This is very, very crucial. So when 0 by 0 form or infinity by infinity, these are all called undetermined form. When such things are comes, what you will do is limit extending to 0. You need to identify why numerator is going to 0. X is equal 0 is a factor. So take x out, x plus 2. Denominator x. Now cancel. X is equal 0, you substitute this one. So when it is 0 by 0 form, you have the factorization method. Next one is the rationalization, depending on the rationalization. Third one is expansion. Fourth one is the best method for most of the competitive exams. That is the El Hospital rule. So you all learned this one in your classes, earlier classes. Now let us move into the certain standard formulas. So here what is the indeterminate form? X is equal to a. For a value x, say x is equal to a. The function f of x takes the value either 0 by 0 form, infinity by infinity, infinity minus 0, tending to 0 into infinity. Because if this is 0, fixed 0, there is no problem. But tending to 0 into infinity, 0 power 0, infinity power 0, a value tending to 1 power 0. Why value tending to 1 power 0? Simple. Anything x, if x is less than 1, infinity goes to 0. The moment x is growth 1, x to the infinity goes to infinity. So there is a deviation coming. So that's why tending to 1, whether less than 1, greater than 1, very, very important. And now here I have given certain important properties. Limit extending to a, x power n a minus a power n by x minus a is n into a power n minus 1. This is also taken as this one, first principle of derivative actually. And x power m minus a power m by x power n minus a power n is equal to m by n into a power m minus n. And the limit x to mod x is lies between 0 to pi by 2. Sin x less than 1 is less than tan x. Okay, and this is very important property, and standard formula is limit extending to 0, sin x by x is equal to 1. Limit extending to 0, tan x by x is equal to also 1. Only difference is here this one approaching from less than, approaching from left hand side. Here approaching from greater than 1. Means this value is coming to 1 but little higher than 1. Here it is coming from the less than 1. Maybe if someone is asking limit extending to 0, step up greatest integer function. Sin x by x is equal to 0. Limit extending to 0, step of tan x by x is equal to 1. And also you can look at some of the basic properties. Limit, standard limit. Limit extending to 0, 1 minus cos x by x square is equal to 1 by 2. Okay. Limit extending to 0, a power x minus 1 by x is equal to log a. Log a base should be e. So here some standard formulas given. Limit extending to 0, sin ax by x is equal to e. Why? I'll write a here, I'll write a, and this value goes to 1, so value will be. Limit extending to 0, tan ax by x is equal to also 1. Okay. Now you look at here, sin x degrees by x. So x degrees, 180 degrees is equal to pi radians. X degrees is equal to how much? X by 180 into pi. So everything you need to write. So pi by 180 will come. Because you cannot write sin x degrees. So when you are applying this one, sin x means x must be in terms of radians. Limit extending to 0, sin inverse x by x is 1. Limit extending to 0, tan inverse x by x is equal to 1. Limit extending to 0, a power x minus b power x by x is equal to log a by b, limit extending to 0, a power x minus 1 by b power x minus 1 is log a by, actually this is comes as log a by log b. I can take it as log a base b also. Next one is when limit tending to infinity, how we will be dealing with such type of things. So here you need to know, for example, 0 less than x less than 1, as x to the power of n goes to 0 as n tending to infinity. X is greater than 1, x to the power of n goes to infinity, and x power minus n goes to 0 as n tending to, what is the value? Infinity. And another thing is, whenever some question is there, x tending to infinity is there, I'll better you take x is equal to 1 by y and y is tending to 0. X tending to minus infinity, y in this case only, y will be tending to 0 minus, x tending to infinity, y will be tending to 0 plus. And look at here, limit extending to 0 a naught. This is the mth degree polynomial. This is nth degree polynomial. If m is equal to n, simply the leading coefficient will be the answer. If degree of the numerator is lesser than the degree of the denominator, value will be 0. If degree of numerator is greater than degree of the denominator, then very simple, if they are of the same sign, will go to infinity. They are of opposite sign, will go to minus infinity. Means maybe you can look at one example here, like limit extending to infinity, x cube plus 2x square by 2x cube. This answer will be equal to 1 by 2. Limit extending to infinity, x power 5 by 4x cube. This value goes to infinity. Limit extending to infinity, minus x cube by 2. This value goes to minus infinity. Or limit extending to infinity, x square by x power 5 plus 4. This value goes to 0. Next one is, so when the indeterminate forms comes, we use the expansion. What is the advantage of using the expansion? For example, limit extending to 0, e power x minus 1 minus x by x square. Yes. How here? You cannot do factorization, but you can apply the L'Hospital. What is L'Hospital? I'll explain. Before that, what happened now? If you use the expansion, I will write it as limit extending to 0. E power x, this one will go this side, this one also goes this side. So x square common, 1 by 2 factorial plus x by 3 factorial, etc. by x square is there. So when you cancel this one, the value is equal to 1 by 2. Similarly, e power minus x expansion, these two are very, very important. This is also important. This is also, some extent, this is okay. With the help of these two only, we will be writing the sin x expansion, cos x expansion, tan x expansion, sin inverse x expansion, tan inverse of x, 1 plus x whole to the power of 1 by x. And what is this one? This is the binomial theorem. Binomial theorem. Okay. So everyone should know what is sin x, what is cos x, what is tan x, what is sin inverse x. Everything one should know this value. And see, if you look at here, some question they'll ask, limit extending to 0. 1 plus x whole to the power of 1 by x minus e plus ex by 2 by x square. What is this value? So if you know this expansion, from here you can write this value minus E plus EX by 2. So this is E into 11x square by 24 plus everywhere x square will be there, x square. Cancel. And this of the value goes to 0. So E into 11 by 24 will come. So expansions are very important. Now, L hospital rule. When to use L hospital rule? So you have limit extending to A like f of x by g of x. This is of the form 0 by 0 or infinite by infinity. In that particular situation, simply differentiate numerator and substitute x is equal to a. Differentiate the denominator, substitute a. For example, if it is coming 0 by, very simple, because when you differentiate that x minus a term will cancel. Now, if for example, if this is 0 by 0, don't worry, you go for second derivative and substitute. And here, we should not differentiate u by v form. You numerator separately and denominator separately. So, numerator separately and denominator separately. Now, for example, anyway, this will be discussed. Okay, limit extending to a f of x to the power of g of x. If it is this base is going to 1, base is going to 1, power going to infinity, I can write L is equal to e to the power of limit extending to a g of x into log of f of x. On simplification of this one, when it is 1 to the power of infinity, simply e to the power of limit extending to a f of x minus 1 into g of x. This is the best way of solving this question. What is the sandwich theorem? Means in a given neighborhood, g of x between f of x and h of x, whereas as extending to a f of x is equal to L and limit extending to a g h of x is equal to L. If this is there, so the mid value also going to be the same thing. Means what is the thing is, this is h of x, this is f of x, g of x is going. So this is x is equal to 1. So when x is equal to 1, this is coming together. So it's a limit L, this limit is L. So mid value also going to be L. So very, very important property, and most of the times we will do this one. So the best example to use this one is like sin x is less than 1, means here where we will do. This is a 1/4 of a circle. Right? Now you take this one. As this theta going to 0, what happened? This area of this one, area of this one, and area of this triangle will come together. So that will be reduced to 1. So the mainly what we use is f of x is less than g of x is less than h of x. As extending to a, f of x tending to L, h of x tending to L, automatically g of x also will tend to L only. Okay. And one major example here, what I want to give is f of x is equal to step x by n into x. So here what happened? X into actually step of x by n is equal to, okay, this is the integral function. So here what happened? X by n minus 1 less than x by n. Step of x by n is less than x by n. Okay. Now, here what is happening? This value, if I write here in, let me write n. So n into x by n minus 1 is less than n into step of x by n is less than x by n into n. So this is x minus n is less than n into step of x by n is less than x. So as n tending to some 0, so this value goes to n, this value x. So this value goes to x only. Okay. So here let me give algebra of limits. So what is this algebra of the limits? Limit extending to a f of x is equal to L1. Limit extending to a g of x is equal to m, L2. Both are finite. Let us assume both are finite. So in that case, limit extending to a f of x plus or minus g of x. Limit of sum is equal to sum of the limits when they are finite only. Limit extending to a f of x into g of x is equal to L1 into L2. Limit extending to a f of x by g of x is equal to L1 by L2, where L2 is not equal to 0. And limit extending to a f of x power g of x is equal to L1 to the power of L2, provided L1 should not be equal to 1. Should not be equal to 1. And here, limit extending to a some new function like h of x minus g of x exist. That doesn't mean that limit extending to a h of x exists and limit extending to a g of x. When these two exist, this will exist, but when the difference exists, the limit of individually may exist, may not exist. So that's why you cannot write every time limit extending to a h of x minus limit extending to a g of x. You cannot write this one as this one. No. Unless until they are finite. Okay. So with this one, I'm concluding this session. Thank you very much. Read those formulas, standard formulas. Very important part of limits are standard formulas and expansion and how to make use of the El Hospital rule. Thank you. See you later.